Hi everyone, welcome to the next video on separation techniques. This video we're going to talk about a separation technique called simple distillation. When do we use simple distillation? Well, let's go back to our previous example where I had a beaker of water. Here I have a beaker of water. We call water is also what we know of as a solvent. That means it's able to dissolve substances. Let's go back to the example of table salt. Table salt is a crystal. It is a solid. It is able to, if I were to put it in water, dissolve in it. Henceforth, we call it a solute. When a solute and a solvent comes together, we form something called a solution. In this case, I formed a solution of salt water. In our previous example of crystallization, we use crystallization when we want to get the solute back from the solution. I want the solid crystal back from the solution. That's when I use crystallization. But what if instead of the solute, I want just the solvent? How are you going to get the solvent out of the solution? Okay. If I were to zoom in, this is what you see. Here I have all the solvent molecules, and over here I have the solute molecules. We've already figured out how we can get the solute back. If we heat up this solution until it reaches saturation point, the solute particles will come back together and then a solid crystal will form again. How are we going to get the solvent? Right? We remember that as we heated it up, this solution up, the solvent boils off and evaporates away. Right? So how are we going to get the solvent if I just want a solvent? So I'm going to introduce you some apparatus that you can use to help you collect back the solvent as it evaporates away. Here, there are several things I'd like to introduce to you. This round bottom flask we refer to as a distillation flask. The more familiar flask you may have seen before is a flask that looks rather triangular in shape. Okay, this is a distillation flask. On the very top, you find that there's a stopper. Looks like there are two things here, but actually it's just one thing. It's a single stopper. This is it in 3D. Okay, this is a stopper. Sticking out of the stopper is a thermometer. Okay, the thermometer runs through the stopper into the flask itself. Okay, so this is the thermometer. Helps us monitor temperature. Coming out of the distillation flask, you find that there's this long tube. This is drawn in 2D, okay, but it's actually a tube. It's like a straw, a glass straw kind of thing coming out of the distillation flask. This is where the water vapor will go through and eventually come out. Here we have again a tripod stand, and below it, you're familiar with this, the Bunsen burner. Alright, so what we're going to put in the distillation flask, we're going to put the solution. Okay, we're going to put the solution, which is the mixture, and we're going to heat it up. Right, and we're going to heat it up. Unlike in crystallization, where we heat up the solution in an evaporating dish, remember, heat it up in an evaporating dish. The problem with that is that when we heat it in an evaporating dish, it just evaporates away into the atmosphere, into the air. Here, we are creating an environment where whatever evaporates away will be, you're right, collected. Okay, it will be collected and runs down this tube. Okay, so this is why we need to create this setup. Usually when we are boiling the solution, the boiling can get very violent. Or because you are supplying a lot of thermal energy, this boiling can get really, really violent. This whole setup may start to shake a lot as it boils. There are actually some things that we will provide in the lab called boiling chips. They're like small little pebble-like things. Boiling chips. What these boiling chips do is that they reduce the violentness of the boiling. Okay, it makes the boiling not so violent, such that the whole setup won't shake like crazy. Right? So just a little fun fact. Alright, so as we heat up the solution, this is what's going to happen. Okay, if I were to zoom in, this is what you see. The water molecules will gain kinetic energy, right? They'll gain kinetic energy, and then they'll start to move faster and further apart, and they'll separate away from the bulk of the liquid, right? And becomes gaseous state. Okay, they are separating away. They become gaseous state. This is water vapor. Water vapor, as you already know, is the gaseous state of water. This is the liquid form of water. That's great. You see, in a sense, I have separated out the solvent from the solute. But I have a bit of a problem. It is in gaseous state. And when it's in gaseous state, and because you know hot things rise, it rises to the top. Where does it go next? Well, it'll go down this tube. Okay, the water vapor will go down this tube. It goes down this tube, goes down this tube. Okay, I'm now going to show you there's a problem right now. As it reaches the end of the tube, the water vapor, like steam, like a kettle, is just going to come out. It's just going to come out and just join the atmosphere, join the air around it. It's like a kettle with a really, really long spout. So we have a problem here, right? This setup doesn't really work. Water vapor will just exit and come out of the long glass tube, and I won't be able to collect it into my beaker. That is a problem. So what do we do in reality? Actually, this setup has one more thing. Okay, there's one more thing surrounding this glass tube. I'm going to introduce this thing to you. We call this thing a condenser. It makes sense, this is called condenser. The role of the condenser is to condense the water vapor. So in reality, I did not show you one final apparatus. This glass tube is surrounded by in a sense, a bigger glass tube. Okay, I'm going to surround it with a bigger glass tube. So imagine like a small glass tube in a bigger glass tube, right? A bigger glass tube. And then I'm going to fill up this bigger glass tube with cold water. I'm going to fill it up with cold water. So how do I fill it up with cold water? Actually, I'm going to put another tube coming out here. Okay, so I'm going to supply through this tube. Let's go in cold water. Okay, so cold water is going into this tube. Okay, so in a sense, I've included a smaller tube onto the bigger tube. Right, cold water is going in and then it's filling up the cavity of the big tube. Notice this cold water that's going in, it isn't seeping into the inner glass tube. It's just on the outside. So it is almost like a water bath. It is surrounding the inner glass tube. It's not going into the inner glass tube, it's surrounding the inner glass tube. This is cold water. By putting cold water, wrapping it around the inner glass tube, it helps to cool down whatever hot steam is going through it. So you see, all this hot water vapor that's going through, it will begin to cool down. Okay, it will begin to cool down and condense. It will condense on the inside. Okay, I show you that there's one tube over here to bring cold water in, right? Eventually, this cold water inside here will start to warm up, right? It will start to warm up. It will start to warm up because the thermal energy is transferred from the water vapor that's going through conduction into the cold water. And then eventually this cold water won't be cold anymore, right? It won't serve its function to condense. So actually, in reality, let's introduce a second tube coming out. There's a second tube coming out to help allow the warm water to exit it. Okay, so warm water can exit. So in a sense, I have a steady stream. Constantly more cold water is going in. Okay, constantly more cold water is going in, while the cold water that has been warmed up leaves it. That way, this whole condenser stays really cool. It helps to cool down whatever water vapor that is coming out and going into the condenser. What does it look like on a microscopic level? This is what it looks like. Okay, let's zoom in. This is the condenser. Right, and you see as the water vapor is passing through, okay, this gaseous water vapor is passing through, because the surrounding environment is really cold, okay, because it's filled with cold water. As a result, they condense. The thermal energy and kinetic energy is being lost from the water molecule to the surrounding cold water, and then begins to condense. It becomes liquid state again. Okay, it's becoming liquid state again. It's losing its kinetic energy to the surrounding cold water. Okay, and as we said earlier on, as a result, this cold water will warm up on the outside. But that's fine. It will be replaced with new cold water coming in from the lower tube. Okay, so as the water molecules condense, they condense, and then they will start to drip out from the condenser. And that's great. Now I have pure solvent going into this beaker. Okay, if I were to zoom in, this is what you will see. Brilliant. All I have now is pure water, just the solvent without the solute. This is no longer a solution, it is just a solvent. I've shown you a lot of the diagram in 2D. Let's look at the apparatus in 3D. Okay, let's look at the apparatus in 3D. Here you see the distillation flask, okay, or here they say distilling flask or distillation flask. Here you see the condenser. Can you see that on the inside there's the inner glass tube that's running through? Okay, this is the inner glass tube that's running through. This is where the water vapor will collect. And then there's this outer glass tube, right? And then you see this is where cold water goes in to fill up the outer glass tube. And warm water will come out from the top. Okay, here we have a receiving flask, or you could put a beaker at the end if you want to. I show you another image to give you another idea. This one's a little bit clearer. Okay, let's zoom in and see. Can you see? Again, this is the distillation flask. Here is the condenser. Can you see that there's this one is a little bit more fancy. This glass tube inside swirls around. Okay, this glass tube inside serves around. So you see there's an inner glass tube. Okay, this is the inner glass tube. There's no real name for it. I'm just calling it the inner glass tube. And then you see on the outside, there is a bigger glass tube, right? This is the condenser. Again, cold water. Okay, I need to connect this to a pipe. Right, cold water can go in. It'll fill up the outer space of the condenser, and then you'll cool down this inner glass tube on the inside, and then warm water will come out from the top. I need another rubber tube running out. Lead it somewhere else, right? So, and then whatever condenses, right, will come out through here, and then it'll go and collect inside here. This is my pure solvent. Okay, so this is what it looks like in 3D. A lot of students have trouble understanding what the setup here looks like. Okay, they don't understand that there is an inner glass tube and then there's a bigger glass tube on the outside that contains the cold water to keep the inner glass tube cool so that condensation can take place. Okay, so that's all there is to simple distillation. Not quite simple, but you get the idea of it. This is what simple distillation is. And maybe one final thing is you may be wondering what in the world is the thermometer for. Well, thermometer here is to help you monitor temperature. And we know, remember, if pure substances boil at a fixed temperature. So for this particular solvent, we know that the moment the thermometer hits 100 degrees Celsius, we know that whatever water is coming out at the other end has to be pure water. Right? Makes sense? When it's 100 degrees Celsius, whatever is coming out on the other end has to be pure water. Okay, so that's all there is to simple distillation. Basically, the idea is that we've created a setup so that we can collect any water vapor that is boiling off and cool it down so that it can collect into a beaker or a flask. And then we have a pure solvent at the end. Okay, we use simple distillation if we want to get back the solvent. We use crystallization if we want to get back the solute. Okay, and that's all there is to simple distillation.